Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Your family, your community, your country, your responsibility. Be the best citizen you can be. Find the Bill of Rights on leadersay.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Chris Smith in London, good morning to you.
Hello, Reedy.
Hi there. Well, Chris, there's a lot that's been spoken about this day, 11th, and 11th of the 11th. 2011. And apart from it being the anniversary of the end of a significant war, what else is special about it scientifically? People want me to ask you.
Oh, the world is definitely going to end today at 11:11. 11, definitely. Just like it did on 10/10/10/10 and all that. I mean, no, there's no scientific relevance whatsoever. There is an interesting date that we have had recently, though, which is that on the 23rd of October.
Yes.
And it works better if you use your sort of dates in an American format, because they tend to say 10/23 rather than 23/10. So 10/23 at 6:02 in the morning or evening, 6.02 on the 23rd of October. This was known as Mole Day. Not moles as in furry creatures that dig up my garden, but moles as in chemical moles. Because Avogadro's number, the famous scientist who came up with the concept of the mole, and the fact that we know how many particles of something there are, so we can do chemical equations and work out things with accuracy. Well, Avogadro's number begins 6.02 times 10 to the 23. So that's one date that does have a scientific relevance. All the others, not really, because, well, you know, we only have time because we've invented the time we call the time we call time.
Yes.
We only have dates because we've set the calendar. So, you know, the millennium was celebrated everywhere, but are we really sure that 2,000 years after Jesus went by 10, 11 years ago? We don't know.
Okay. So, Chris, I hope then I won't have to, on the 12th of December next year, ask you this question again. It's done, right?
Well, you can do, but we'll probably answer it
the same way. Okay. Talk to me about this new injection for people to lose weight.
Well, there's a paper in Science Translational Medicine this week. It's by a lady from the University of Texas called Renata Pasqualini. And although it's not in people yet, it's been trialed, and that's what they're announcing in this paper, in primates. So what they do is they've got access to a primate facility where there are lots of fat monkeys. And so I asked her, you know, how do you get these fat monkeys? And she said, well, just like humans, in any facility, there are some monkeys that are a bit lazier than others, and they do less, and so they get fat. And she said, so they picked out the ones that were more fat than others, and then they put them on a course of injections with this chemical for a month, and they shed up to 40% of their body fat and lost 14% of their body weight without any other ill effect. And it's very clever, this. What the injection contains is a short protein, a little string of amino acids, and they are chosen because they specifically recognize or glue themselves onto a signature which is in blood vessels only in fat cells or supplying fat cells. So in other words, this protein addresses itself when you inject it just to the parts of the body where there is fat. And it's coupled to another short protein sequence which, when this gets into cells, it causes structures called mitochondria, which are the cell's powerhouses, to break down, and this kills the cell. So in other words, by using this clever coupling of these two short protein sequences, you can selectively destroy fat. And it's like having a chemical liposuction. And so they wanted to do the test because, as they say in their paper, obesity carries an equivalent lifetime cancer risk of using tobacco. And so everyone knows that smoking causes lung cancer and a host of other cancers, breast cancer in women, endometrial cancer, that kind of thing. But not many people are quite as acquainted with how bad for you obesity is and what a threat the world faces because of it, because of the attendant health problems. So something like this agent, which is called adipotide, that's what they're dubbing it, could be very promising. And they're now about to start a clinical trial in patients, probably in the next year or so.
Okay, very interesting. And then traces of chemicals found when the Earth was first formed?
Not the Earth, but the whole universe.
The whole universe.
There's a very nice paper in Science Express this week. It's by a guy called Michel Fumagalli, who's a graduate student at the University of California, Santa Cruz. And he and his colleagues have got this paper where they describe how they've used a very powerful telescope called the Keck 1 telescope in Hawaii to spot these two clouds of gas in the universe, which are pristine clouds of gas left over from the Big Bang. Because we're all comfortable with the idea that about 13.7 billion years ago, the universe popped into existence because there was this gigantic explosion, and enormous amounts of energy was unleashed, and that energy was then converted into matter, and we don't know quite how that happens yet, but that's what the LHC is all about trying to understand. And the results of that explosion were lots of the gas hydrogen, a little bit of helium, and then a trace of lithium, and those are elements number 1, 2, and 3 in the periodic table. But in order to test out our theories of what we think the Big Bang should do, without some samples of the gas that it produced to test those theories against, it remains just that, a theory. Every single time people have tried to find traces of gas to test theories against, they've always been contaminated with large amounts of metals. And what that tells you is that gas is not pristine because the metals are made by stars. But this gas contains tiny, if hardly any traces of metals at all. The metallicity, as they're calling it, is less than 100 times less abundant than you'd find in other traces of gas in the universe. And so what they've effectively found are some of these gas clouds that probably spawned the stars and things that the whole universe subsequently produced in its first galaxies and that kind of thing. And so it's a really good model to test these theories against. It's written up in Science this week.
All right. Give us a call, guys, on 021-446-0567, 011-883-0702. The Naked Scientist is here to take your calls, to take your questions. 31702 is the SMS line, and 31567. There's an SMS, Chris, from Julie. She sent it last week, and she wanted to know, after having radical nerve surgery, why is it so hard for doctors to treat nerve pain?
Well, one of the problems with injuring nerves or cutting nerves or repairing nerves is that when you section them, either after surgery or during a nasty accident when nerves can get broken or torn, the nerve cells don't always grow back. Sometimes when you injure a nerve cell badly like this, the cell that lives next to the spinal cord that produces that nerve will actually die. And the consequence of that death is that the part of the spinal cord that nerve would communicate with and send messages into is then devoid of any inputs. And what can happen is that adjacent nerve fibers, which still connect to the spinal cord, can branch and send supplies into this disconnected bit of the spinal cord and start stimulating it. And if those nerve cells stimulate a part of the spinal cord that would normally signal pain or pain sensation, and they now start to get driven or stimulated by nerves that are not pain nerves, you can start to feel pain when the nerves that actually sense other things like temperature or fine touch, just stroking or just gentle sort of tickle to the skin. So you start to interpret that innocuous stimulus as a noxious, painful one. And so this rewiring we get in the spinal cord is part of the reason why you get these neuropathic pain states. There's another thing that's being looked at, which is that when nerves get injured, you also produce chemicals called prostaglandins. And prostaglandins they're part of the inflammatory system, and they lure the immune system in, but they also appear to persuade neurons to rewire themselves in this way in the spinal cord. And there was a paper in the journal Science earlier this year by Professor Peter McNaughton at Cambridge University, where they've actually begun to find out how this works in rats. So the next step, now they can actually make this happen reproducibly, is to start looking at the actual wiring that's going on. And so the question is, if we can work out why the nerve cells are miswiring themselves in these injured states, maybe we can put in some drugs to stop this miswiring happening in the first place, or in the longer term, actually reverse the miswiring that's gone on at the moment. But at the moment, we just can't do that, which is why some people are left with these debilitating syndromes that painkillers just won't touch,
work.
Because the painkillers target inflammation, and there is no inflammation happening in these chronic pain states, so they're very hard to treat.
021-446-0567, 011-883-0702. We'll take your calls when we return. Please stay on the line.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
And we go to Keith in Randburg. Thank you for holding on. Good morning.
Hello, Reedy. Question for Chris. Chris, I recently heard a talk show by Neil Armstrong, first man on the moon, that if people go to Mars, when they return, they might have to wait years before they can land on Earth again. Why would that be? I'll listen on the radio if you don't mind.
Okay.
Hello, Keith. Well, this is interesting because, of course, in the last 7 days, we've seen Russia's mission to Mars ending. It wasn't really a mission to Mars. It was locking a whole bunch of people up in a warehouse for the time it would have taken them to get to Mars. The whole point of doing this was to try to understand the sort of psychology, how hard it is for people to cope with extended journeys on spacecraft and that kind of thing. So that's part of it. There's a psychological aspect. But also, extended voyages in space aren't really what humans have evolved to do, because we've evolved to live on Earth where we have gravity pulling us down all the time, and gravity is really important for keeping our bones strong. And if you spend any period of time in microgravity without taking steps to make sure that your bones are preserved, then it's possible to age your skeleton to that of someone who is about 100 years old very, very fast. And initially, when people started exploring in space, they did not account for the fact that without the weight of gravity working on your joints and on your bones could be lost. And they had terrible osteoporosis when they came back. So now astronauts do load-bearing exercise. I think there's a real concern if you were in space for the extended period of time. You'd have to take very careful precautions to make sure that you didn't have that particular problem. Why you wouldn't be able to come back to Earth immediately if you did take those precautions, though, I'm not sure. So if anyone has an answer to that one, I'd be grateful for some help.
All right, let's go to Patricia in Four Ways. Hi.
Hi, Reedy. Hi, scientist. I'm sorry, I've forgotten his name.
It's Chris.
Chris. Hi, Chris. Quick question. I've always wondered about this. Why do people have tongues in their mouths that are different, in the sense of mine has got cracks in it, my brother's got even worse cracks in, and some people have a smooth tongue? What causes that?
Well, I think it's the same as saying, why do we have earlobes, where some people's earlobes are separate from the bottom of their the face where they join the cheek, and others are continuous. There's no sort of split or crack there or line there. It's all down to natural variation. The tongue is a huge chunk of muscle. In fact, it's a collection of several muscles all working together, coated by a layer of epithelium, in other words, tissue that just protects it. And the tongue develops when we're inside our mothers, when the rest of the body develops. And as a result, there's a degree of randomness about how the cells put themselves together. So they're following a general plan, which is how the body puts itself together, but there's a degree of randomness about it, in the same way that there's a degree of randomness about fingerprints. And so as a result, everyone has a tongue that is broadly the same, but if you look closely enough, it's all slightly different.
All right, let's go to Mamadi in Braamfontein. Hi.
Hi, Reedy. I'd like to ask the doctor what polymyositis is and how it can be treated, and where can we get assistance for my aunt who has been diagnosed with the symptom.
Polymyositis. Okay.
I missed the word that was the problem. Sorry, say again.
It's okay. Polymyositis. Mitosis.
Ah, polymyositis.
Yes.
Okay, well, polymyositis is a disease that is an inflammatory condition of muscles. Poly means lots of, myo means muscles, and itis means swollen up. And so this is an inflammatory condition involving muscles, which is where the immune system is causing muscle damage when it shouldn't. And usually this condition arises because of an immune problem, or some other condition has then triggered the body to start attacking the muscles for some reason, or making the muscles become inflamed. And usually it's a way you treat it by damping down the immune response in the muscles. And it can be linked to a whole raft of different problems or underlying causes. So the treatment will depend partly on controlling the symptoms, pain and function, and also partly on treating the underlying condition, and then damping down the inflammation. I know that's a slightly woolly answer, but obviously I can't comment specifically on this case because I don't know what's going on in this case.
Mm-hmm. Is it serious, Chris?
Well, it can be,
okay.
But it can also be treated. So you see this in connection with a number of different conditions, and some of those conditions are more complicated to treat than others.
All right. Good luck to your aunt, Mamati, and thanks for calling us. Let's go to Irvin in Greenpoint.
Hi. Good morning. Chris, I'd like to ask you about pigeons. When one observes a pigeon pair, they're usually the same color and the same markings, and there are a variety of markings and colors in pigeons. How do they get this right, seeing that neither pigeon knows itself what it looks like? I'll listen on the radio.
Well, that kind of assumes that pigeons do know what they look like. I'm not sure if pigeons do know what they look like. Do they?
I don't know. I have no clue.
We know that pigeons and we know that many animals recognize each other really well. We also know that certain animals can actually recognize humans really well. There was a paper that was published in the journal PNAS about 2 or 3 years ago, and it was looking at mockingbirds. Now, I know mockingbirds aren't pigeons, but they're very close relatives. And in this particular experiment, there was a group of researchers who went up to these mockingbirds and disturbed them in their nest, and the birds would become angry, and then the researcher would retreat, and then they go up to the nest again, and the birds would become angry, and the researcher would retreat. And so this time, now that you can say, well, the birds obviously recognize that person, they know that they're a pest, and they react to them. So if we send in another human, a different human now, presumably the birds will be equally alarmed by the new human coming in, because they're just alarmed in general. So they sent in a different researcher to go and disturb these birds, and they reacted much less viciously and violently to the first approach of this person than they would to a reapproach of the first person, and because they clearly could discriminate the person who was the pest before from the person who is the new person approaching. So, in other words, birds don't just recognize other birds, they can also recognize other people, and they're doing it visually. Birds have very good eyesight, and they therefore use their eyes to pick out elements of the terrain, elements of each other for threats and that kind of thing. And birds are also social animals. They live in big flocks, they fly around together, so they need to know who's friend and who's foe. So probably that's where it comes from. And they have these markings and things, and they've evolved to be sensitive to markings and plumage, because that's how you tell who your friend is and who your foe is, who might be trying to eat you. And I guess that's probably at the bottom of how it works with pigeons. Whether they recognize each other is a different question than whether they recognize themselves and really know what they look like. But that's a slightly different question. We don't think pigeons have a theory of mind. We don't think pigeons, if they looked in a mirror, would know it was necessarily them in the mirror rather than a different bird that is the reflection. Because dogs certainly can't recognize themselves. If you show a dog it's a reflection, it thinks that the reflection is another dog, and it keeps trying to get round behind the mirror to try and find that dog so it can play with it. It doesn't realize it's itself. Newborn human babies don't recognize themselves until they reach a threshold age when they suddenly know that reflection is them.
Yeah.
And some animals, like dolphins, also can do this, but then as soon as you get to slightly lower animals, suddenly there's a sort of a failure of that bit of the brain to take on board it must be a reflection. And I think pigeons probably would struggle to know it's them.
I have an email here. It's very long, but let me just summarize it. This person, anonymous, is asking about donor eggs and wants to know, is it possible for the recipient's DNA to reject the donor's egg? And if the egg has a genetic predisposition to certain diseases or viruses, would that transfer to the recipient?
Right. Okay. When you do egg donation, usually this is done because a woman cannot produce viable eggs of her own. This can happen because the woman has a genetic problem, so that if she were to become pregnant, the baby would be endowed with a genetic problem, and this is not ideal, or the baby wouldn't be viable, or because there's something wrong with the lady's ovaries. They've been damaged, or they have lost their eggs, they've run out of eggs, and so you need to get a new supply of eggs. The fact that the DNA is different in the egg does not matter, because the whole point of having sex, and what we're talking about sex is biology, mixing up genes, is to produce a baby that is genetically different to the parent. And the woman's body, the immune system, is specially rigged up so that the woman can tolerate having something inside her which is genetically different from her, because half of the DNA in any baby is genetically distinct from the mother, because half the DNA in a baby is dad's DNA, and so therefore the baby is half genetically not compatible with the mother. And the immune system in the mother is specially rigged up to tolerate that and make sure that there's not a problem.
Oh.
If there are viruses and that kind of thing in the sample, that's a different matter, and steps are taken when people are going through things like IVF and that kind of thing to test people to make sure that they're not carrying things that could be transmitted and that there might be a risk. So usually there's screening done. There shouldn't be anything genetically that could pose a threat to the recipient, though, and not that wouldn't be found by screening anyway. So it's a safe procedure, although there are inherent risks in any procedure, and harvesting the eggs in the first place from the donor person can also be risky as well. So it's not something to be undertaken lightly, because it is quite demanding. The hormone cycles you have to go through to prepare the body to receive the egg and that kind of thing, they're all quite demanding procedures, both physically but also mentally. And many people who have to go through all this kind of thing will say it's mentally very, very demanding, very, very tiring, and there's a lot of heartache involved as well, because it doesn't always work.
All right, Chris, thank you very much for chatting to us. We'll see you again next week.
Pleasure. Thanks, really.
Ta-ta.
Have a great week. Bye-bye, everyone.
Bye. That's Chris Smith, the Naked Scientist, and the podcast will be available at around 1:15 or 1:30. Let me just say, it's not possible to just tweet or email everybody, individual links of podcasts. It's just physically impossible. But we never say a podcast is on our website unless it really, really is. And we never leave this building unless we have checked. So I harassed Thomas in the early hours of the morning on a Saturday, on a Sunday, saying there's a complaint about this podcast, and then we look through it and it's there. So try it several times. Maybe there are, sometimes there's something wrong in the process of downloading it, and go through to the website, and it's not difficult really, because you click on my page and you'll find best of, and you'll find a list of podcasts. And when I told you 2 weeks ago that we can only keep 10, it's actually more than that. We obviously don't have a podcast from January or last year or March. But if it's something that has happened recently that we did podcast, I guarantee you it is there. And if it's there, it is complete.